Welcome. So I'm assuming you have at least these prerequisites installed on your computer. Let's get started by creating a folder somewhere on our computer, perhaps in your home folder. I'm going to create a folder called How to Host Things on Google Cron Jobs. And let's open this folder with VS Code. And if I pop open the terminal built into VS Code and take a look at where we are on the file system, you can see we are in this folder that we just created. Now let's create our dev container. If you're unfamiliar with the term dev container, hold tight. It's going to make sense in a few minutes. In our empty folder, let's create the following folder in files. Let's create a folder called .dev container. Inside of this .dev container folder, let's create a file called devcontainer.json. And at the root of our project folder, let's create another file called dockerfile.dev. And let's populate the devcontainer.json file with this content. And let's populate the dockerfile.dev with this content. This code looks a bit hectic, but it's actually useful. This code will build a little mini computer called a container that runs on top of our base machine, aka our laptop or desktop or whatever we're using. When we're done with this walkthrough, we can simply kill or delete this container, and our base machine will be left clean from all of the software that we installed into the container. In addition to helping us stay organized, the use of containers is highly compatible with cloud platforms like AWS, GCP, and Azure. So when we get to the point where we're deploying this application to the cloud, it'll make that process super easy. To shed some light on what these files are doing, the dockerfile.dev configures our container, and the devcontainer.json file tells VS Code how to attach to our container when we'd like to edit the files inside of it. Take a closer look at the dockerfile.dev, and we can see we're installing Python. We're installing Git. We're installing gcloud. This is going to allow us to speak to GCP from inside our container. And we're also installing a Docker client. This is going to allow us to speak to the Docker server running on our base machine from inside our container. FYI, when you use a container for the purposes of developing software inside of it, we call it a dev container. Later in this video, when we ship our application to GCP, we're going to make a second container. We're going to refer to that second container as our production container. Because our dev container and our production container are going to be so similar, there's a high likelihood that our code will work exactly as it does in our development environment when we run it in GCP. In a nutshell, using this approach is going to make shipping our code to the cloud very easy. If none of this makes sense, don't worry about it. Let's move on. We can interact with Docker completely from the command line, but Docker also comes with this tool called Docker Desktop. Docker Desktop is a UI for interacting with Docker. And on my local Docker instance, you can see at the moment I have no containers and I have no images. Let's come back to our editor, aka VS Code or Cursor, whatever we're using, and let's type these keystrokes, Shift Command P. This will open up the command palette as it's so called. And in the command palette, you should see an option if you've installed the dev containers extension that says dev containers reopen in container. You can also search for it. Let's select this option and see what happens. When you build a container from your Docker files, the process will usually take a few seconds, maybe a few minutes. It depends on how much software you're packing into the container. So it looks like the build process has completed, and let's come back to Docker Desktop and see what things look like. You can see we now have a few images, and we also have a container. This is our dev container. Let's come back to VS Code or whatever we're using, and let's pop open the built-in terminal and look at where we are on the file system. And you can see now we are in a folder at the root called code. We are no longer in the original folder we created. Moving forward, we will be developing our application inside of this dev container. Let's quickly confirm all the software we'll need is installed in this dev container. We have Python. We have Git, we have gcloud, and we have our Docker client. So everything's looking good. Let's save our progress in a remote repository on GitHub. If I come over to my GitHub account, I will create a new repository called How to Host Things on Google Cloud Run Jobs, and click Create Repository. And there are times for creativity, and this is not one of them. So let's just follow these commands right here. Let's initialize our local repository to be tracked with Git. Let's create a commit. So I'll save all of these changes. And I'm using Git shortcuts that were outlined in the dockerfile.dev. And let's rename our branch to be called main. Let's add our Git remote, as it's so called. This lets our local Git project know where to push code to. And then let's push our code. We can see our project has been backed up. If you have a keen eye, you're thinking, what just happened? So long story short is, whatever credentials were authenticated to GitHub with on our base machine get forwarded to the dev container when it's launched. Here we are in the dev container. If I type git push, we can see we're authenticated with GitHub. That's our remote in this scenario. And if I run this same command in this project folder on the host, we can see we're authenticated as well. So on Mac, there's this application called Keychain Access that stores credentials for us when we authenticate with different systems. I think the corresponding application on Windows would be Credential Manager. On Linux, it would be libsecret. But anyways, so here in the Keychain Access app, we can see a stored credential for GitHub. So if I delete this and try to authenticate with GitHub again, we can see we're prompted for our credentials again. And then let's try it in the dev container. So if I say git push, we're prompted for our credentials again. Here is how I suggest we authenticate with GitHub. So here we are on the page for our newly created repository. If we come to our profile settings, there's an option that says developer settings. You can see this personal access tokens drop down. GitHub has this newish feature called fine-grained tokens. Let's click on that and let's generate a new token. We'll call this token How to Host Things on Google Cloud Run Jobs. And let's restrict this token to only be able to access the repository we just created. This one. And if we open this repository permissions drop down, let's add contents, read and write permissions. And the only other permission we'll need is metadata permission, but I think this is always enabled by default. And let's generate the token. And we can use this token, let's copy it, to authenticate with GitHub in a very controlled manner. So if I perform this git push command again, it'll prompt for my username. And if I provide that access credential, or that token rather, now we're authenticated again. And if I come to the dev container and try pushing again, we're authenticated in the dev container as well. So long story short is your host machine or base machine credentials or authentication with Git gets shared with a dev container. So we're probably not going to need this personal access token again from GitHub, but let's store it just in case we do need it. So what I'll do is create another file at the root of our project called .env. And let's store this GitHub personal access token as it's called. So I'll say GitHub personal access token, and then I'll paste it in here. And let's also add a .git ignore and make sure that we ignore this .env. Come over to this link. And when you develop Python projects, there's a whole host of files that you do not need to add to GitHub or Git for that matter. So let's add them all at once right now. And I think that does it. So let me save this. So if you have any issues authenticating with GitHub from the dev container as a backup, you can just use a terminal on your host machine. So I will see you in part 2. In part 2, we'll learn how to deploy a simple job to Google Cloud Run. As we're starting from scratch, let's create a new project in our GCP account by coming over to console.cloud.google.com/welcome. It's going to load one of the projects in your account. And if we click this dropdown right here, it'll open up a modal that includes a button saying new project. Let's click on that and create a project called How to Host Things on Google Cloud Run Jobs. Let's click create. And all of the GCP related work that we will be doing will be done inside of this project for organizational purposes. After our project is created in GCP, let's select it and search for Cloud Run in this top search bar and select the option that says Cloud Run. Cloud Run is a managed service for running containers. On the Cloud Run page, you'll see 2 tabs, one that says Services and one that says Jobs. Services in this context are long-running applications like HTTP APIs that need to be listening to the internet for requests. Jobs, on the other hand, are for triggering scripts. These scripts will release the resources needed to run them immediately upon script completion or failure. As this video covers Cloud Run jobs, let's run a simple job to get our feet wet. First, let's authenticate with GCP in our dev container by typing the gcloud init command. And this will take us through an auth flow. And I'll say, yes, I would like to sign in. And if I command click this link and copy it, come over to whichever browser tab or browser instance I'm logged into GCP with and paste it into the URL bar, I'll be able to select my account and I have to give consent and my password, more consent. And then I'm presented with a auth code that I can copy and paste into the terminal that kicked this whole auth flow off. And I'll be asked to select my project, which is 3 for me. And now the dev container is authenticated with GCP. Okay, many gcloud commands are going to ask us to reference our project ID. So let's create a variable for it so we don't have to constantly type it, right? And some gcloud commands require us to specify another identifier for our project, which is called its project number. You can find the project number by coming over to the dashboard of our selected project. And you should see the product number displayed here. Let's copy it. And yeah, trust me, you're going to be very happy that you just did this. So now let's set up our project so that we can run Cloud Run jobs inside of it. So by default, this is the list of GCP APIs that are enabled in a fresh out of the box project. GCP has hundreds of APIs, and now let's enable 2 more of them. And the APIs that we will enable will be the Cloud Run API and the Cloud Build API. And after that completes, let's list the enabled APIs on our project, and we can see that this list has grown by 2 entries. This next command will give the Cloud Run API in our project permissions to talk to a number of other APIs in our GCP account. Okay, that takes care of all of the permissions and APIs we need to enable in order to run a simple Cloud Run job. So the high-level overview of what we're going to do for the remainder of part 2 is First, we're going to build a little application, a very simple application. Then second, we're going to ship it to Cron Jobs. So our little application is going to require 6 more files to be added to our project. These 5. And then we're going to have a helpers folder that will hold 1 file. And let's populate the main.py file with this content and the requirements.txt file with this content and the proc file with this content, the dockerfile.prod with this content, the cloudbuild.yaml with this content, and the sayhello.py helper with this content. As we can see, a Python Cloud Run job project is really not that different from other Python projects. So as usual, let's install our dependencies. And that should make this import error go away. If it doesn't go away, try opening up the command palette and restarting the Python language server. But that did fix this import error. And now let's run our script. And it works. So we've built a little application. We've tested it out. Now let's ship it to Cloud Run. The left half of this diagram shows what we have done up till this point, and the right half of it shows what we're about to do. Deployment step number 1 will be to create a repository in Google Artifact Registry. A repository in this context is a place where we can store images. When we build a Docker file, we are left with what is called an image. An image in the context of Docker is a collection of files that defines all of the code and operating system requirements needed to run a particular application. If we recall to when we built the dev container, we remember seeing a few images and a container inside of the Docker desktop UI. When this image, holding all of the configuration of our dev container, was ran, it left us with this container. When we build a Docker file, it leaves us with an image. And when we run an image holding all of the code and operating system requirements of a particular application, it leaves us with a container. We are now going to build our second container, aka our production container, by building the dockerfile.prod into an image holding all of the code and operating system requirements needed to run our application in Google Cloud Run. Because our development container and our production container are going to be so similar, there's an extremely high likelihood that our little application will work exactly as it did in our development container when we run it in Google Cloud Run. If we take a closer look at our dockerfile.prod and our dockerfile.dev, we see the only difference between the two is the removal of a handful of tools. In the dockerfile.prod, we don't need Git, we don't need gcloud, we don't need Docker. These tools are not necessary when running our application in production. So now you understand why Docker is so useful. When you take code that's written on your computer and ship it to other computers without defining all of the operating system requirements it needs, it increases the likelihood that it's not going to work. So what Docker does is package your code with all of its OS requirements so that when it's shipped to other computers, there's a higher likelihood that it will work. Finally, now let's create an image repository in Google Artifact Registry by entering this command. But before we enter this command, let's come over to the GCP console and come over to the Artifact Registry page so we can compare the before and after. And now let's enter this command. And when that completes, let's come back to the Artifact Registry page and reload it. And now you can see we have an image repo. So for clarity, an image repo is not the same thing as a Git repo. An image repo is a place where we can store images, and a Git repo is a place where we can store code changes made to a particular code base. So now that we have this set up, let's build our production image and store it in this repo called repo for job 1. First, we'll do this using cloud build. If we pop open the cloudbuild.yaml file, we'll see a script with 2 steps. Step 1 is building the dockerfile.prod, and step 2 is pushing the resulting image to the repository we just created in Artifact Registry. And the URLs of repositories in Google Artifact Registry have to follow this specific format. If they don't follow this format, things will not work. And the last thing I'll mention is we can see that there is a colon at the end of the repository URL followed by a string. This is the tag of a particular image. This is a way that we can give a custom ID to each image that we store in a particular repository. The default tag is latest. This hints to us that this version of the image is the latest one. And we're not going to be using this tag feature pretty much at all, but it's useful to know about, and it's useful for QA. And sometimes you'll use the git hash to identify each version of a particular image. This is useful for storing a history of all the versions of an application, etc. So anyways, let me stop rambling and let's build our production image and store it in the repository we just created by sending it to cloud build with this command. While that's building, I'll come back to the GCP console, and you can see that inside of our repository, we currently have no images. And when this script is finished, we should see an image inside of our repository. Okay, the script finished in cloud build. Let me reload this page, and now you can see we have an image inside of our repository. And second, we'll do this with a Docker client inside of the dev container. All right, this is what this looks like. We have to build the dockerfile.prod and tag it with the appropriate image URL format or repository URL format. And notice how we're also including this platform flag that reads Linux AMD 64. I'm guessing the hardware that powers Cloud Run is provided by AMD. And we have to retrieve an access token from GCP. And then we log into Artifact Registry like so. So we provide this access token as the password. And that worked. And then we have to enter this command. And when we push our image, it should work. And it does. Now that we have our production image stored in a repository in Google Artifact Registry, let's run our first job ever. We finally made it back to Cloud Run. So let's come over to the Cloud Run page and come over to the Jobs tab. And what we're going to do is register a job with Cloud Run that uses the image that we stored in our repository as the application that will get triggered when we trigger the job. So here's what that looks like. This is the command that will register a job in Cloud Run Jobs. Here we specify the job's name. First Cloud Run job ever. And here is where we reference the image in Artifact Registry that we would like to use as the application that gets triggered when we trigger the job. So if I enter this command and come back to the Cloud Run page, when that command finishes executing, we can see we now have a job registered in Cloud Run Jobs. And here is how we trigger the job. So we execute this command and provide the job's name. And if we come over to the Cloud Run dashboard again and select the job, we can see the job's logs here. And we should see the same exact output that we were seeing when we were running this application in our dev container. And there we go. We see the same logs that we were seeing in the dev container. So that's great. We now know how to manually deploy containerized scripts to Cloud Run Jobs. Next up, we'll automate this deployment process using GitHub Actions. We are now going to automate the deployment of our simple job using GitHub Actions. The way that we do this is by creating a folder at the root of our project called .github. And inside of this .github folder, we're going to create another folder called workflows. And inside of this workflows folder, we're going to create a file called CICD.yaml. Here is the content that we will paste into this CICD.yaml file. And by placing this YAML file at this specific location of our project, whenever we push to the main branch of our GitHub repository, this code inside of it will automatically get triggered. If we look closely at this CICD.yaml script, we can see it's requiring us to specify some GitHub variables, as well as a GitHub secret. The way that we provide these values is by coming over to our GitHub repository. And you should see a tab that says Settings. In the Settings tab, there is an option that says Secrets and Variables, and it has a sub option that says Actions. On these two tabs is where we can provide our secrets and our variables. First, I'll provide all of the variables. One of the variables of our CICD script is going to be our project ID. And the next one will be our project number. And the next one will be the name of our job in Cloud Run. And second, let me show you how to generate the secret that we'll need. So if we come over to console.cloud.google.com and make sure our project is selected, if we come over to the IAM and admin option and select the service accounts sub option, here is where we can create a service account, which is a fancy way of saying a username and password that we give to an application so that it has the permission to do what we want it to do. So let's create a service account, and I'm going to call this service account How to Host Things on Google Cloud Run Jobs CICD Service Account SA. And we'll add a description so that we know what this is for. If we come back to this a while from now, done. To the key now, you might have noticed that there was already a service account sitting in this list before we ever created a service account. So by default, GCP creates this default compute service account, as it's so called, and gives this service account to a number of APIs so that they have permissions to do what they need to do. So now if we select the service account from this list that we just created and come over to the Keys tab, we'll see this drop-down button that says Add Key. Let's create a new key. We'll use the JSON key type. Click Create. And a file will be downloaded to our computer, and the contents of this file will be our secret. So let's copy the contents of this downloaded JSON file and come back to our GitHub repository and create a new secret. I'll call it GCP CICD SA key. Then we'll paste in our service account key, add our secret, and then that takes care of setting up all of the secrets and variables for our CICD.YAML script. Now we're ready to test out our CICD automation with GitHub Actions. Let's come over to the Actions tab on GitHub. And we have nothing here at the moment. And let's come back to our project. And let's push our latest changes to GitHub and see what happens. Okay, so we need more permissions added to our personal access token. So let's come back to GitHub and come over to the settings section, and let's come over to the developer settings option, find the personal access tokens drop down, come over to fine grained tokens, and here's our personal access token. And we need to add more permissions. Okay, so we need workflow permissions. And let's try to push again. All right, that worked. Come over to the actions page and reload. So as we can see, it failed. And if we click on the automation, we can see that we're failing because we're not able to upload images to Artifact Registry. This is the command that will grant our service account those permissions. So now we can re-trigger our CICD automation. And it failed. And it's more permission stuff. This is the command that will grant the next slew of permissions we need to give to our service account. And it looks like it worked. And it's more permission stuff. So this is the command that will give our service account the next slew of permissions it needs. And it looked like it worked. Our automation completed successfully, so we're definitely moving in the right direction. Now what we're going to do is check out the logs of the Cloud Run job, and we're going to make an update to our application and confirm in the logs that our update gets propagated to the Cloud Run job hosted on Google. So let's test this out. Here is the command that will trigger our job. We can see that it got triggered again, right? And we get more logs. So now what we're going to do is let's make an update to our application. Instead of saying hello, let's, say, hello, daddies. And let's save this change. Push it. And in GitHub, on the Actions tab of our repository, we see that another run of our automation is in flight. And after this has completed, we're going to trigger our job again, and we should see this line in the application logs say, hello, daddies. All right, so it completed. And now let's trigger our job again. And we see our job got triggered for a third time, and it just completed. So we should have some more logs, and indeed, this log line got updated. So everything is working. In part 4, we're going to learn how to automatically trigger our job on a regular schedule using another GCP product called Cloud Scheduler. In order to use Cloud Scheduler, we need to enable the Cloud Scheduler API. So let's do so by entering this command. And when that completes, if we list out all of the enabled APIs in our project, we should see an additional entry. Here we are, Cloud Scheduler API is now enabled. Now we can create a cron job. A cron job, for those who have never heard the term, is a scheduled task that runs on a regular interval. The way that we define the interval for a cron job is with this expression format. For example, this would be the expression for once a minute. This would be the expression for every Monday at 9 a.m. This would be the expression for the 1st and 15th of each month at 2 p.m. And this would be the expression for every 5 minutes between 8 a.m. and 10 a.m. Here is the gcloud command template for creating cron jobs in GCP with Cloud Scheduler. The only variable whose value we don't yet have is the service account. So let's create a new service account with the minimum needed permissions to trigger jobs in Cloud Run. And this time, let's create the service account using the command line. All right, here's how we create service accounts from the command line. And now we need to add invoker permissions for Cloud Run to this service account. And this is how we do so. And if we list out all of the service accounts in our project, we see we have 3 now. So in the gcloud command template for creating cron jobs with Cloud Scheduler, let's replace the variables with the following values. Before we enter this command though, let's come back to the console and come over to the Cloud Scheduler page. And we currently see no Cloud Scheduler jobs displayed. So if we enter this command now, when it completes, we should see a cron job registered in the console, and we do. And if everything's working as expected, if we come to Cloud Run and take a look at the page for our job, we should see it getting triggered once a minute. Yep, you see that? So yeah, as we can see, everything's working. We see our cron job listed as a trigger here on Cloud Run, and our application logs are also getting printed out each time the job gets triggered. So this is fabulous. We now know how to set up cron jobs on Google Cloud Run jobs.